Okay, can you please tell me about yourself in very short?
Yeah, I have 2.5 years of experience in the IT industry. So my main focus is on product development and application maintenance and operational side. So my core expertise in the Java with hands-on experience in building microservices based applications and working with cloud platforms like AWS. So in addition to that, I have the little bit of exposure in web technologies like HTML, CSS, JavaScript, React, and some experience with Angular as well. So I have like contributed to into in development activities to like almost three projects and including requirement analysis, coding, debugging, testing, and deployment. So apart from that, I have also worked on the CI/CD pipelines with tools like Jenkins and Git, and integrating code with build tools such as Maven. And the while deployment, I have also used Docker. So yeah, so these are the experience I have, and also for the database side, I have experience using SQL and JPA Hibernate. So yeah, these are the technologies I have worked on and about myself.
Okay, what version of Java currently you are using?
Yeah, currently we are using Java 17. So Java 17 is there in our system. However, mostly we use the features of Java 8 and 11.
So, what are the features you are aware of?
Yeah, in Java 8 we have streams, Lambda expression, functional interfaces, optional classes, then new datetime API. So all those things are there. And again in Java 11 we have a var keyword in Lambda and new string methods and HTTP client API. So all those things are there. And in Java 17 I'm aware of the features like sealed classes, then switch expressions and text blocks, and also there is something with respect to instance of. So yeah, so these are the features I am aware of.
Okay, can you tell me what is switch expression in Java 17?
Yeah, so switch expression actually traditionally Java switch like it was a statement, so it was not an expression. So that means that it did not return any value. So we used to write like let's say switch, and inside that if anything is whatever the value can come, and then we used to write like case one, and then the some comparison, and then break, and then case two some comparison, and then break, like that we used to write. But now from Java 17, we what we can do is like we can also return the value. So earlier it was not returning the value. Now it can be used as an expression and it returns the value. And we can use arrow level like we do with the lambda expression, similar to that. It also supports multiple case levels in a single branch. So yeah, so now we can simply return the value. So yeah, so that's the difference between the newer version and the older version of Switch.
Okay, do you know there is a keyword called yield in switch?
Yield, yeah. So basically, suppose there is a complex logic is there, and then we want to return the value. So basically, yield returns the value from the switch. Yeah. So let's say any in the default or any section, let's say we have a string some message equal to something, then we can just say yield that message. So it will return that string message.
Okay, what about the sealed class?
Yeah, sealed classes are the new features in Java 17 that let us control which classes or interfaces can extend or implement a particular class or interface. So basically, it helps in for the better encapsulation, we can say. Let's say we have a like public sealed class, any let's say shape is there, shape class is there. So there we can just say permits like whatever shape, let's say circle, a square, rectangle. So we can give the permission to all those circle, square, rectangle. Now only these circles, rectangle, square can only like extend the shape. So it is this shape is limited to only these classes only. So that's the benefit of using the sealed classes.
Okay, but what benefit you get by doing this?
Yeah, we it gives better control over the class hierarchies, and it also improves the security and maintainability of the APIs. So all random classes are not going to extend like any random different class or something or interface. So it is limited to something. So that is a much better way to write the code, and it also works well with the pattern matching in switch expression. So yeah.
Okay, fine. So what is functional interface?
Yeah, functional interface in Java is an interface that contains exactly one abstract method, and it can have it can have any number of default or static methods, but only one abstract method. So that is what we say the functional interface. And we have one annotation called at the rate of functional interface, so that we can give on the top of the functional interface. Uh,
So is it mandatory, this annotation of functional interface?
No, no, it is not mandatory, but it's better to have if we are trying to write any functional interface, because if suppose we break the law of abstract methods and static methods, whatever we are writing, so like suppose we are writing more than one abstract method, then obviously it is not the functional interface. But if we don't have this annotation in that interface, so we will not know like some mistake has happened, and we are this current particular interface is not a functional interface anymore. But if we have this annotation of at the rate of functional interface, in that case it will be showing the compilation error. So we can see that okay, there is something wrong, and this particular current interface is not functional interface, so it won't compile itself. Yeah, so that's the advantage of using this annotation.
Okay, can you tell me some built-in functional interfaces?
Yeah, we have many, like we have runnable, callable, comparator, then consumer, supplier. So all these are functional interfaces.
Okay, so tell me one thing. So we have a comparator functional interface, right? And it has two methods, compare and equals. So is comparator a functional interface even though it has two methods, compare and equals?
Yeah, so comparator is a functional interface because it has only one abstract method, that is compare, and this equals method which is there, which you are telling, so that method is basically inherited from the object, so it does not count towards the function interface requirement. So anything coming from the object class, so that won't be counted for the this abstract method.
Okay, so what is marker interface? Do you know?
Yeah, marker interface in Java is a interface that does not declare any methods or fields. So it is also called as like tagging interface, because it is used to mark a class with some metadata, so that the JVM or a framework can apply a special behavior to these classes. So for example, we have serializable, then clonable and all. So those are the marker interfaces. So basically this is used to tell the compiler or framework that the class has some special property, and it is used I means mostly before the annotations were introduced in Java 5. So yeah, so that's what is the marker interface. Yeah.
Okay, so do you know the difference between all match, any match, and none match? All this?
Yeah, all match is that returns true if like all elements in the stream match the given condition. So let's say we have a array list of, let's say, even numbers 2, 4, 6, 8, like that, and we stream on top of that, and then we say let's say all match, and then we say lambda expression like input and n%2 equal to 0. So it will return true because all are even. So basically it will check every element, so and it will return the boolean result actually. So that is what is all match, and any match returns true if at least one element matches the condition. So now again, let's say we have like same like some different elements like 1, 3, 5, 8, but in this case only 8 is the even number. Now this any match will return true. Why? Because at least one element is the even. But in this case, if we run all match, in that case it will return false. Now same way, if we have none match, right, so it returns true if no elements match the condition. Okay, so for example, if suppose we give all odd numbers in the array list, so in that case only it will return true, otherwise it will return false. So that's what is the difference between these three. Yeah.
Okay, so whenever suppose you write any stream API, so we have collectors.toList, right? And we also have collectors.toSet and collectors.toMap. So can you tell me the difference between all these three?
Yeah, so collector.toList that collects the element of the stream into a list basically, and it preserves the insertion order like an array list we have. So it just simply it will whatever we have as a input, so all that it will print as output. Okay, and it also allows duplicate. And suppose if we have collectors.toSet, and in that case let's say again we have a array list and we say stream on that array list, and then we say collect and collectors.toSet, and let's say in the list we have duplicate elements, like let's say we have a and then b c, like that. So in that case also it will, like, since it is a set, so only unique elements it will print, so only a b c will be printed. Now coming to a map, so it collects the elements into a map like kind of key value pairs, and it requires two mapping functions, so key and value mapper. So key is for the key and the value for the values. So it basically throws the illegal state exception if duplicate keys like that occur in the stream. So let's say we have a stream of let's say a, then let's say bb or some c like that. Okay, so in that case let's say if we want to count like how many times a is there and b is there and c is there. Okay, so in that case we can along with the actual element we can also hold the count of that. Okay, so for that purpose we use this map.
Okay, so what is the difference between double equal to and equals?
Yeah, double equal to is used for reference comparison when dealing with the objects, and it checks whether two reference points are to the same memory location. And in case of primitive types, it compares actual values. So let's say if we have let's say int a equal to 5 and again b equal to 5, and when we say a double equal to b, it will be true. But let's say if we have a string and a string s1 equal to new string of, let's say, again a, and again new string of, again in that also a is there, although the content is same, but if we will equate here s1 double equal to s2, it will return false. But if we say s1 equals s2, in that case it will return true because it will compare the content only, not the actual object.
Okay, let's say we have integer a equal to 200, and again we have another again integer b equal to 200. Okay, now what will be the output if we say a double equal to b?
Okay, so a integer a equal to 200 and integer b equal to 200, and we are saying a double equal to b, not equals, right?
Yes.
Yeah, so double equal to, and it is 200, right? So it will be false actually.
Okay, why so?
Yeah, why? Because Java caches the integer value in the range of minus 128 to plus 127. So that is the integer caching. And since it is 200, so it is out of that range. So that is out of that cache range. So that A and B is kind of different objects now. So now whenever we are going to compare A double equal to B, it will be false. But if suppose we do equals, if we are using, in that case it will be true.
Okay, can you tell me the difference between final, finally, and finalize in Java?
Yeah, final is basically a keyword, and it is a modifier that can be applied to variables, methods, or classes. So its meaning changes depends on the where it is being used. So if it is final variable, then value cannot be changed once assigned, so it will be acting as a constant. Okay, and if suppose if it is along with the method, like final method is there, then it cannot be overridden by subclasses. So that's the meaning of it. And then coming to final class, so it cannot be extended, so no inheritance can be done. So that is what is the final class. And then coming to finally, so finally is a block basically. And so it is mostly used in the exception handling that is always executed, so whether an exception is thrown or not. So it is used for resource cleanup, so like closing files, releasing connections and all. So it always executes basically. That is what is the finally. And then finalize is a method that defined in a object class, and it is called by garbage collector basically before reclaiming the memory of an object. And however, it can be overridden by a class to perform cleanup activities before the object is destroyed. So that's what is the finalize.
Okay, so finally always executes.
Not always. So like um, finally block like usually it executes, but there are some exceptions. So if the try block completes normally, no exception. So in that case, the exception is thrown and caught in the catch block. And if there is a return statement in try or catch, the finally block executes before the method return. And finally may not execute. Suppose system.exit we write like in the try block. In that case, it will just come out of it and it won't go to the finally block. And also suppose if JVM crashes or any kind of power failure happens, in that case also obviously finally will not run. And also if suppose the thread is killed before the finally block executes, so in that case also it won't execute. So yeah, these are the few exceptions we can say when the finally does not execute.
Okay, can you tell me the difference between out of memory error and stack overflow error?
Yeah, out of memory is happens when the heap memory has the issue. So heap is full or something like that. In that case, out of memory error will happen. And stack overflow happens whenever the JVM stack space for the method call is exhausted. In that case, stack overflow will happen. So out of memory usually happens when we create a new object or data structure in the heap. And stack overflow usually happens due to the deep or infinite recursion kind of thing is happened. So that's the basic difference between these two.
Okay, what is the difference between fail fast and fail safe iterators in Java?
Yeah, fail fast iterator basically it throws concurrent modification exception if the collection is modified structurally after the iterator is created. So let's say while iterator is going on, then itself in the middle we say let's say remove method or something. So we try to modify the existing collection. So in that case, this concurrent modification will happen. So this fail safe iterator basically does not throw concurrent modification exception. So it works on a copy on the collection, uh, not the original one. So for example, we have concurrent hash map, then copy on right array list. So we have for array list we can use a copy on I right array list, and for map we can use concurrent hash map iterator. So in that, if suppose if we try to modify it or add it something, so it won't throw the exception because uh, we already have the original one and we are working on the copy of it. So it won't throw the error. So that's what is the difference between these two. Yeah.
Okay, can you tell me how many types of memory management are there?
Yeah, in Java, memory is managed in multiple areas like heap. So that heap stores the object and instance variables and is divided into young and old generations for the efficient garbage collection. And then we have a stack, so that holds the method call frames and local variables and references and yeah, so basically this cleared automatically when the method completes. And then we have meta space. So basically this was introduced in Java 8. So before that we had permgen. So this meta space basically stores class metadata and resides in the native memory. And garbage collectors manage heap memory to prevent leaks. So so it has various algorithms like serial, parallel, G1, GC, and all. So all those algorithms they have. And then again in Java 11, like epsilon garbage collector has been introduced. So that is uh, useful for testing, but it does not reclaim the memory. So yeah, so these are the types of garbage collectors we have.
Okay, so in Spring Boot, what is prototype design pattern?
Yeah, in Spring Boot, the prototype design pattern is implemented by making a bean with the like a scope, and then we can put prototype. So that annotation we can use. So by default, Spring beans are singleton. So that means that the same instance is shared across the application context, whole application context. But when a bin is defined with prototype scope, so Spring creates a new instance every time the bin is requested. So that is generated from the context. So basically, this allows independent state for each uses. So this is useful when the multiple clients or components need their own copy of a bin to avoid the share the mutable state. So yeah, so that's what is the prototype.
Okay, can you tell me the scenario when we should use it?
Yeah, the prototype design pattern is ideal when we need, let's say, multiple independent instances of a bean. So each basically maintains its own state rather than sharing the single instance as in a singleton. So for example, when we handle the user session data or temporary calculations, or let's say uh, like other similar kind of things, then we don't want to change in one instance to affect another instance, right? So another scenario is like batch processing or workflow engines. So here each task requires its own copy of a service or object to avoid interference between the parallel execution. So these are the like few scenarios when we should be considering the prototype design pattern.
Our prototype beans are thread safe.
Actually, each instance is independent, but thread safety depends on the bean's internal state. So prototype beans do not automatically make the code thread safe, but it depends on the uh, like bean's internal state. Yeah.
Okay, so can we mix this prototype bean with request or session scope in web application?
Yeah, prototype beans can be injected into request or session scoped beans, but we should be quite careful while doing this kind of design to see the proper requirement, and then only we should proceed for this kind of situation.
Okay, So can you tell me how Spring Boot is different from Spring Framework?
Yeah, Spring Boot is a framework built on top of the Spring framework only, and it simplifies the creation of production ready applications by providing auto configuration, embed servers, and opinionated defaults. So, unlike traditional Spring, which requires extensive XML or Java configuration, Spring Boot requires minimal boilerplate codes, and it allows the developers to start application quickly with minimal setup, and focus is basically more on the business logic instead of the configuration. So that's what is the difference between these two. Yeah.
Okay. And what are starters in Spring Boot? Can you give the example?
Yeah, starters are pre-configured dependency sets that simplify Maven or Gradle configuration by automatically including commonly used libraries for a specific feature. For example, Spring Boot Starter Web is one of the starter that includes Spring MVC, then embedded Tomcat, Jackson, and all. While again we have Spring Boot Starter data JPA is there, security is there. So JPA, for example, it provides the JPA and Hibernate, so we don't have to separately go and include it and add like different jars and combinations. We don't have to do that. It will automatically include the whatever relevant jars will be there, and the corresponding correct version it will include. So that's what is the starter in Spring Boot.
Okay, so what is Spring Boot auto configuration and how does it work internally?
Yeah, auto configuration in Spring Boot automatically configures beans based on the dependencies present in the class path and properties defined in the application properties or YAML file. So internally it uses at the rate of enable auto configuration and at the rate of conditional annotations to load beans only when the specific classes or conditions are present. So basically, it allows the developers to focus on more business logic rather than the configuration. So that's what is the Spring Boot auto configuration.
And what is at the rate of Spring Boot application and which annotations it includes?
Yeah, this Spring Boot application annotation is a uh, like combination of the add configuration, add enable auto configuration, and add component scan. So these are the three underlying annotations under this, and it makes the main class of a Spring Boot application and enables component scanning, automatic bean configuration, and configuration class registration, and it makes it easier to bootstrap the application with the single annotation. So we don't have to separately add all these annotations. So yeah, so that's what is this added of a Spring Boot application.
Okay, so suppose you want to exclude auto configuration classes in Spring Boot. So how can you achieve that?
Yeah, auto configuration classes can be excluded using the exclude attribute in a Spring Boot application annotation. So, for example, we can use added of Spring Boot application, and then we can just give exclude equal to and whatever the configuration class is there that we can mention. So that will automatically exclude it. Yeah.
And do you know what is Spring Boot CLI and how it is used?
Yeah, Spring Boot CLI is a command line tool, and it allows developers to write Spring application using like I think Groovy scripts and run them without full project setup. So it simplifies the prototyping by automatically compiling scripts and providing embedded servers. So it makes it easy to test small applications or microservices very quickly. So yeah, so that's what we rarely use it, but yeah.
Okay, what is at the rate of qualifier annotation and how it resolves the bean conflicts?
Yeah, at qualifier is used alongside of with at the rate of auto add to specify which bean to inject when multiple beans of the same type exist in the context. So without at qualifier, Spring would throw some exception, and it allows kind of control over the dependency injection in multi-bean scenarios. So yeah.
Okay, so what is the difference between request param and path variable annotation?
Yeah, request param basically extracts query parameter from the URL. So suppose URL we have something user and ID question mark, then ID equal to 1. So from there it will extract the query parameters, and path variable basically extracts the values from the embedded in the URL path. So for example, we have user and then ID and then forward slash 1, like that. So from there, if we want to fetch the value, then we will use path variable, and if it is question mark and then ID equal to 1, like that, then it is query parameter, sorry, request parameter. So yes, this is the difference between these two. Yeah.
Okay, so can you explain the whole end-to-end flow of microservices? Like how client send requests and how the response goes back to him or her?
Yeah, so in microservices, first of all, any client request is sent. So this process begins with the client is using any web browser or any mobile application or any other service. It may be directly also any API hit it will be doing. So it sends the HTTP request usually through the REST API call. So now we will be, let's say, through path variable we might be hitting it, like let's say get then orders and then forward slash 1 to 3 to fetch the order detail. So after that, all the client requests go through the API gateway. So the request first hits the API gateway, so which acts as a single entry point, and this API gateway has the various responsibilities like routing the request to the appropriate microservices, then authenticating and authorizing using JWT and all, and also rate limiting, caching, and load balancing also done here. So all these requests go through this API gateway, and all this validation kind of thing happens here. And then we have service discovery which comes into picture. So the API gateway uses service discovery like Eureka and all. So to find the available instances of the target microservices. So dynamic discovery uh, is done here basically. So for all the services which are deployed, so they register here on the Eureka, and each microservices will be having might be having the multiple instances, and each instance will be the dynamically deployed somewhere, so that where it has to be deployed, that is dynamically generated at the this Eureka. Okay, so now as soon as the request is routed to a specific microservices, so that is responsible for the functionality. For example, let's say order service it goes, and it handles the order related operations, so all those business queries logic happens, and it hits the database if it is there, and then it gets the data, and all those things are done here. And then uh, inter-service communication also may be done while all this process. So often microservices need data from the other services also. So again here other services can be called either through the synchronous way or asynchronous way. So is in like synchronous way like REST APIs and all, and asynchronous ways like messaging queue, Kafka, RabbitMQ and all we can be used. And then database interaction also might happen. So each microservices will be having its own databases, and then once all these calculation happens and we have the data which has to be sent back to the user, then uh, uh, after processing the microservices it sends the response back to the API gateway, so which may perform additional steps like it may be logging and caching. All those things can again be done here. And then finally the API gateway sends the processed and aggregated response back to the client. So it might be in the again JSON, XML, or whatever the format we have asked for. So in that format it would be there. So this is what is the whole format of the microservices and flow. Yeah.
Okay, what is the difference between JPA repository and CRUD repository?
Yeah, in Spring Data JPA, CRUD repository is the base interface that provides the basic CRUD operations like save, uh, find by ID, find all, delete by ID. So all these are there. Those are the basic CRUD operations. And JPA repository extends CRUD repository and adds more advanced features actually. So it includes pagination, sorting, and batch operations and all. And it also supports JPA specific methods like flushing the persistent context like and all, and saving and immediately flushing, save and flush and all. So all those things are provided by the JPA. And also JPA repository allows defining custom queries like JPQL or SQL via add of query annotation we can use, and it make more flexible for complex databases operations. So typically CRUD repository is sufficient for simple CRUD operations, while JP repository is preferred in production grade applications that requires more advanced queries and more functionalities. So that's what is the difference between these two. Yeah.
So can you tell me in very short how do you achieve the pagination?
Yeah, in JP repository, pagination and sorting are implemented using the pageable and sort interfaces. And this pagination allows fetching the data in chunks or pages. So that is useful for large data sets to avoid loading everything into memory at once. So we can pass a pageable object to repository method so that specify the page number, page size, and sorting criteria. So for example, let's say we have a order repository is there, then order repository find all will be there. Okay, and then again we have the page request interface is there, and then off we can put in that, and then like from which number to which number, so it will be taking the size of the orders, and also like sorting how it has to do, and which parameter based on which parameter it should do. So all the information we can put here. Okay, so that will fetch the data like from 0 to 10 like that if we have given, and the sorting criteria also whatever we have given based on that. So yeah, so GPA repository automatically handles the SQL query generation for pagination and sorting. So yeah, so that is very much useful in case of pagination. So yeah.